Okay, so in this video, I'm going to introduce how to use if statements in Bash. An if statement is kind of the cornerstone for almost any programming language. So are loops, but if statements are like really necessary for computation. And thankfully, Bash, or maybe not so thankfully, Bash really like turned it up to like an 11 with how weird it designed if statements. So this part of these videos is going to be super weird. I'm just going to show you some common gotchas. I promise you, if I didn't prep for this lecture, I would probably not be able to write any of these from the top of my head. All I do remember is that you can use if statements, some common gotchas that happen with them, and I have a handy dandy reference linked that tells me what kind of sub command am I trying to run to do any of these things, because the syntax is so weird. So again, if you find yourself looking at the references for today's lecture a lot when trying to write your own if statements, that is completely and utterly normal. The if statements in Bash are just so strange. So what I'm going to do is I'm just going to quickly type out an if statement, and then I'll explain kind of all of the components to it. So I'm going to make a variable called A and a variable called B. And then I want to say, like, if A is greater than or equal to B, I'm going to say if A is greater than or equal to B, then echo A is greater than B, and then phi. Okay. Isn't this just so wonderful and intuitive what this is trying to do? Absolutely not. So if statement is if statement. This condition is trying to encode is A greater than or equal to B. The way they did conditions in Bash is whack. So it turns out that these square brackets aren't like in Java where you have parentheses. This opening square bracket is actually an alias for a command called test. So it's actually running a command here. And this test command has a bunch of weird syntaxes for how you can define any test you want. And so first it takes the variable A. And then so because it decided that they don't want to support like intuitive characters like greater than sign, equal sign, use -GE for greater than or equal to, and then the character B, and then a ending square bracket to end off the command. And then just like with the for loop, we use a semicolon to kind of finish off that part of the line. And then the opening curly bracket for the body, instead of being do, is then. And then to close the if statement body is phi, if backwards. Isn't that all wonderful and intuitive? It's great. If you want to, now there are lots of options that you could do here. For example, if you want less than, it's LT. If you want equal to, I think it's EQ or E. I don't remember. It's all in the slides. There are so many different random kind of ways you could do comparisons and different codes for them. It's so strange and it is not intuitive. So definitely go back and have that when you're trying to write an if statement, have the if statement section of the slides open so you remember kind of what codes you need to pass in here. Now, importantly, what I do want you to know is it's very crucial that you have spaces around everything here. So you need a space after the opening curly bracket or the opening square bracket and before the closing one. The reason is those square brackets are commands. And so just like how you need to put a space after grep and before what you're searching for, you need to put a space after the opening square bracket. So that's like a very common gotcha, is incorrect spacing. Now, don't worry, it only gets less intuitive from here. It's actually not too bad if you want to talk about like else and else if. So if you want to have an else block, it's very similar. You just type else, and then you could type in, well, I want like echo A is not greater than B. If I go ahead and run this now, you can see that A is not greater than B because it goes into the else. You can also totally do else if, but in the world of Bash, they call it elif for else if. And then it's just like an if statement in some sense. So you could say like if A is equal, if A is equal to B, then print out echo A is equal to B. And then you can run this. So yeah, Weird, weird, weird syntax. And again, I promise you, you're not going to memorize these, or I guess you can if you want to, but I don't. But I just like look at this general pattern, and I look at these slides every once in a while when I need to write an if statement, and I use one of these codes here as appropriate. Now, one of the reasons that they do this, why they have all of these weird codes, is because there's actually lots of possible things you can test for. There's these kind of straightforward, well, not straightforwardly named, but like ones that you'd expect from like a programming language like Java. But Bash has a lot of extra things that you might want to do. For example, what if you want to figure out if a file exists? And so there's lots of other kind of these commands that you can use for things like, does a file exist? Do you have permissions to use something? So for example, if I want to do if a file exists, I could do something like if -f for file exists, something called file.txt. Then I'm going to type out echo file.txt exists. Otherwise, I'll type out file.txt does not exist. And then I end this off with a fi. So if I run this demo, it says file.txt does not exist because this -f, does file exist, failed. If you look, I don't have a file.txt here. But if I go ahead and touch file.txt and then run this, it now says file.txt exists. So yeah, very strange syntax, but you could use this -f to figure out if a file exists. Now, with these if statements, I'm going to go ahead and remove file.txt. With if statements, you can go ahead and actually get more and more complex. So you could do things like and or and not if you want to. So what I can do here is change this. If I want to do or, you could use your good old friend, the double or operator. So that's one thing that does make sense in the if statement world, which I guess is a nice thing to be thankful for. If you want to say like if file.txt exists, or if other file.txt exists, then we can echo file.txt or other file.txt exists, and other file. Now, if I run this, you could see that because neither of those files exist, both of those statements in the or fail, and so it goes into the else branch. But if I touch other file.txt and run this, we see that because one of them evaluated to true, the whole if statement evaluates to true. There's a whole host of other random things you could do here. So if you want and or negation, there are some intuitive things, but the syntax, the specifics of the syntax is strange. So I'm going to refer you back to these slides to see like how you might go ahead and do something. So that's if statements. The weirdest part of this language. It is very strange, not intuitive at all. So totally okay if you found that confusing. I just wanted to highlight those big gotchas, the spacing, the general syntax, and the fact that you have these really weird looking codes to do greater than or less than and stuff like that. The last thing I want to talk about in this video is this thing that's an important thing in the Bash programming world called exit codes. And exit codes are ways of trying to determine if a command you just ran succeeded or not. You may or may not have seen this in some of the programs that you've been writing in CSE 351, but I wanted to make sure that we got a chance to talk about this. Whenever a program ends, it gives an exit code to the caller to tell them whether it succeeded or failed. Now, to get the exit code from, I'm going to actually close this tab. To get the exit code from a command, like if I type ls, if I want to find what the exit code was from that last command, there's a special variable called question mark to know, well, did the last command succeed or not? Now, it prints out 0 here because any successful program, one that ran without failure, its exit code for success is 0. So 0 means the absence of errors. There were no errors, so it ran successfully. Now, if I went ahead and typed like some other random command and it just failed, if I type in echo $question mark, $question mark, it now gives me an exit code that's non-zero to tell me it failed somehow. So anytime you run into an error, like if you try to remove a file that doesn't exist, you get this kind of invalid or non-zero exit code indicating failure. Now, one thing to mention is that there's generally not consistency in what the non-zero numbers mean. The only thing that we guarantee is that 0 means success and non-zero means failure. Certain programs might have a convention to tell you, oh, if you get this exit code, this is what happens. If you get this, this is what happened. But this is not a general rule. It's up to the developer to document what they mean by different exit codes. And so generally, the only thing you can depend on is 0 or non-zero, rather than any specific numbers like 127 or 1. Those are generally not well documented. Now, if you're writing your own script, the way you exit with a particular exit code is you use the exit command. And if you exit, it takes an optional argument for what exit code you want. So if I type in 127 and run demo.sh, you can see that it prints out in my here. If I print out what the exit code was, it was 127. In fact, if you've noticed, I have a special prompt for Bash that changes the prompt based off the last command's exit code. When the last exit command fails, it shows a little X character, and when it succeeds, meaning it had a 0 exit code, it prints out a little check mark. And that's just comparing against what this $question mark variable does. So that's if statements, the weirdest part of this language, and exit codes. In the next and final video for us is talking about kind of an applied demo to kind of tie all these ideas together and to do a little bit of course wrap up, kind of looking at the course as a whole.